hope everyone has joined. Okay, so let me share my screen. Okay, till now we have studied about your plane sedimentation. So in your plane sedimentation, we have learned that the suspended particles, those specific gravity greater than 1, so those particles or suspended particles, they settle down easily. Okay, they settle down easily, but what happened to those whose specific gravity is less than that of water? Okay, so those suspended particles, or you can say those very fine suspended particles, they when they flow to the next level. Okay, they because they keep on floating. Okay, they don't settle down so easily. Okay, since they are very very fine particles, and those are very light, so they keep on floating in the water. So what can we do to those suspended, very fine suspended particles? So what is done, that is your in your next step, that is your sedimentation aided with coagulation. Okay, so here, in that water, when it flows to the next part, so some chemicals, okay, some chemicals are added to the water. Okay, and those chemicals, it is known as your coagulants. Okay, so coagulants or chemicals, or also in other words you can say coagulants, are added to the water in the sedimentation tank. Okay, so what will happen when you add coagulants to that water? It will, after thorough mixing, okay, after thorough mixing of that in that water, it will form a gelatinous precipitate. Okay, and that gelatinous precipitate, it is also called as floc, FLOC. Okay, so what happens, these that fine suspended particles, also you can say as colloidal particles, also you can say. Okay, so those fine suspended particles or colloidal particles that are those are present in water, it what happens as soon as you mix coagulants. Okay, so a gelatinous precipitate is formed, and that fine particles, or colloidal particles, it gets attracted and absorbed, okay, in these flocks. This They get attracted and absorbed in these flocks, and what happened, they form a bigger size particle. Initially their size was very fine. Okay, for that reason they keep on floating. Okay, they kept on floating, but now as soon as you have mixed coagulants in the water, so as soon as you add coagulants and you mix that water thoroughly, so it forms a gelatinous precipitate, and which is called floc. And those after the formation of floc, those particles, those fine colloidal particles, they get attracted and they get absorbed in these flocks, and they form a bigger size flocculated particles. Okay, so as soon as they become bigger sized flocculated particles, so what will happen? Obviously, now their weight has increased, so they will automatically, in the under the force of gravity, they will settle down easily. Okay, so that is the work of your coagulation. So that is the work of your coagulation. So basically what they do, the colloidal particles, they basically possess some charges. Okay, you can say they possess some charges. Okay, and these coagulants, when you mix these coagulants, they first destabilize the particles. Okay, or you can say they destabilize the, because the particles, they keep on floating, they are not stable particles. Okay, so this coagulants, when you mix the coagulants, the particles, the colloidal particles, they destabilize. Okay, and after destabilization, they agglomerate. What is agglomerate? Agglomerate means what? Combine. Okay, they combine, they, what happened, they attract the other particles. In their sidewise, many particles are there. So as soon as the coagulants are added, what did the coagulants do? They first stabilize the particle, destabilize the particle, and now they attract the sidewise particles, or you can say they attract the charges. Okay, the surface charges they attract, and so that particle, it becomes a heavier particle now. And after forming a heavier particle, those particles, it settles down at the bottom of your sedimentation tank. Okay, and after that it can be easily removed. Here, so basically here in, okay, here you can write these sentences. Okay, the sentences you see: very fine suspended mud particles and the colloidal matter present in water cannot settle down in plain sedimentation tank of ordinary detention period. Such particles can, however, be removed easily by increasing their size, by changing them into flocculated particles. Okay, so we have already learned that in your one of the numerical, I told you the difference between discrete particle and flocculated particle. Okay, discrete particles are those particles that do not change their shape and size, and flocculated particles are those particles which changes their shapes, size, and weight of the particle. So that is known as your flocculated particles. Okay, so for this purpose, certain chemical compounds called coagulants are added to the water, which on thorough mixing form a gelatinous precipitate called floc. The very fine colloidal particles present in water get attracted and absorbed in these flocks, forming the bigger sized flocculated particles. Okay, so next you can write, okay, so there is two terms. One is your coagulation and the other one is your flocculation. Okay, there is two terms. You need to know what the terms mean. So let's see. You see here, coagulation is a chemical technique which is directed towards the destabilization of the charged colloidal particles. Okay, flocculation, on the other hand, is the slow mixing technique which promotes the agglomeration of the destabilized particles. So this one already explained. Okay, just there is a technical term you should know, that coagulation and flocculation. These two terms, they go hand in hand. Okay, so first you have added the coagulants. Okay, so the process. Okay, the coagulation, it is a no, after adding the coagulants, it is a chemical technique which is directed towards the destabilization. As I already told, two mechanisms are there. One, as soon as you add the coagulants, it destabilizes. Okay, it destabilizes the charged particles. Okay, destabilize the charged particles, and that technique is known as your coagulation. And what is flocculation? After the particles they become destabilized, okay, the slow mixing technique, okay, after you you slowly mix the coagulants, they will agglomerate, okay, the particles, it will come together. Agglomerate means it will come together to form a bigger sized particle, okay. So that process is known as your flocculation. Clear? So if the question comes like what do you mean by coagulation and flocculation, you need to write up to here, okay, 2 marks or 1 marks like that. Okay, then next is you can write the use of coagulants is generally necessary for clarifying raw water containing turbidities greater than 30 to 50 milligram per liter. Okay, you can write this line. Okay, so up to here, if you write about your sedimentation aided with coagulation, uh, then it's fine. Okay, some short notes it might come. Action. Now let's see. Since we are telling that coagulants are being added to the water, so we need to know what kind of coagulants, what are the chemicals that are being used as coagulants. Okay, so there are different coagulants you see here. Number one is your use of alum. Okay, use of alum. See here, use of alum as coagulant. So what is alum? You first see. Alum, it is the name given to the aluminium sulphate with its chemical formula as Al2SO4 3 into 18H2O. Okay, so the chemical name for alum is your aluminium sulphate. Okay, what is alum? It is aluminium sulphate and its chemical formula is Al2SO4 3 18 water H2O. Okay, so the alum when added to raw water reacts with the bicarbonate alkalinities which are generally present in raw supplies so as to form a gelatinous precipitate of aluminium hydroxide. So when alum is added, it reacts with the bicarbonate alkalinities which are already present in raw supplies and it forms a we have already learned no after adding the coagulants it forms a gelatinous precipitate and the name of the gelatinous precipitate is here is aluminium hydroxide. Okay, so your this flock, that means this talking about the aluminium hydroxide, this aluminum hydroxide attracts other fine particles and suspended matter and thus grow in size and finally settles down to the bottom of the tank. Okay, so this is a see the chemical equation. Okay, you need to remember, there is no other way out. You need to remember the chemical formulas for each of the coagulants. Okay, uh, I can't give you any easy way, but this one you have to remember. Okay, chemical formula. Please try to remember this chemical equation. So here it is. You can see the precipitate. Okay, the flock as your aluminium hydroxide. Okay, so aluminium hydroxide is your flock here. Okay, so you see From the above equation, it becomes evident that the addition of alum to water imparts permanent hardness to it in the form of calcium sulphate. Okay, so calcium sulphate, you see, it gives calcium sulphate. So it imparts this calcium sulphate. It imparts permanent hardness to the water. Okay, the carbon dioxide gas. You see the carbon dioxide gas here. It gives what corrosiveness. It causes corrosiveness. Clear? So aluminum hydroxide is the flock here, gelatinous precipitate or flock here. Calcium sulphate is your, it imparts permanent hardness to the water, and your carbon dioxide, it causes corrosiveness. Okay. So next you see this line you can write, since the alkalinity in water in the form of bicarbonate alkalinity is typical at pH below 8.3 and above the pH 4.5 or so. It fixes a limit on maintaining an optimum pH value of about 6.5 to 8.3, which is required for the formation of a good sweet flow. Okay, so that means in your while you add alum to the water as coagulant, the pH value, it is between 6.5 to 8.3. This point you need to remember. Okay, what will be the pH value then when you add alum to the water? So the pH value, it becomes 6.5 to 8.3. Okay, so another line you can add here is this one. The amount of alum required for coagulation depends on the turbidity and color of the raw water. Okay, so how much alum you will, require for that raw water, it will completely depend on the turbidity and the color of the raw water. What is turbidity? We have already learned in your previous chapters. Okay, previous topics we have already learned. So it depends upon completely on your turbidity and color of the raw water, and also you can write this line also. The dose of the alum may vary from 5 milligram per liter for relatively clear waters to 85 milligram per liter for highly turbid waters, and the average normal dose is about 17 milligram per liter. Okay, so the dose of alum, it for clear water, it is between, it may vary from 5 milligram. Okay, from 5 milligram, and to when it is very highly turbid, then you can increase the dose of alum to about 85 milligram per liter. But the average, normal dose, it is about your 17 milligram per liter. Okay, so this is all about your alum. Next is your next is your use of copperas. Okay, use of copperas as coagulant. So let's see what is the chemical formula for copperas and what is the name. Uh, Ma'am, can you please share the previous slide? Now or later should I share, or you want to take screenshot? Okay, you want to see. Okay, just this one. You want to take screenshot? Those who want to take screenshot, you can take. done. Okay. Then now, use of copperas as a coagulant. Okay. So let's see. Copperas, it is the name given to ferrous sulphate. Okay, these are all chemistry. Okay, if you love chemistry, if you had loved chemistry in class 12, then it will be easy for you. Otherwise, it's a little bit hard to remember the chemical equations, I know. But then also please try to remember the chemical equations anyhow. Okay, because it's important, the chemical equations, because for this topic, if you don't remember the uh, chemical equations, then if you don't write the chemical equations, then this is of no use. Okay, so basically we need to know what is the precipitate. Okay, what is the precipitate. So what is we need to know the gelatinous precipitate. So that is the important thing about this topic. Okay, so you try to remember anyhow. If you see daily, then I think you will be able to remember. Okay, only four of them are there, so it will be easy for you, I guess. Okay, so you see here, copperas, it is the name given to ferrous sulphate, and chemical formula is your FeSO4 7H2O. Okay, so copperas is generally added to raw water in conjunction with lime. That means ferrous sulphate, it is added with lime. Okay, and lime may be added either to copperas or vice versa. Okay, means your ferrous sulphate, it can be added to lime, or either in a vice versa way, lime can be also added to your ferrous sulphate. Okay, ferrous sulphate, or in short you can say as your copperas. Okay, so let's see this one equation. Okay, it is when your first lime is added. When your lime is added to your copperas, then this is your chemical equation. Then when copperas is first added, okay, when you see, when copperas is added earlier to lime, then this equation takes place. Okay, and this equation, you see, this is, this is a continuation process. Okay, actually this is a continuation process. This, you see, ferrous hydroxide, this ferrous hydroxide, they are again breaking it to, or they are adding it to, they are oxidizing the equation. Okay, they are giving oxygen to again ferrous hydroxide, so that your precipitate is formed, named as ferric hydroxide. Okay, ferric hydroxide is formed as a precipitate, so that will be your flock. Okay, that will settle down. So these are a continuation process, you need to remember the equations. Then we can write this line also. Copperas is extensively used as a coagulant for raw waters that are not colored. Okay, so those raw waters which are not colored, okay, so you, in that case you can use copperas as your coagulant. Okay, then it is generally cheaper than alum. Okay, it is a good thing, it is a cheaper than alum, and functions effectively in the pH range of 8.5 and above. So you need to remember the pH also for each and every coagulant. Okay, so when pH value is this much to this much, then this alum is this coagulant is used. So you need to remember the ranges of pH. Okay, so for copperas, when the raw water pH value is between it is 8.5 and above, then you can use copperas as a coagulant. Then it is written here, for colored raw waters, it is however not used, as it does not give any satisfactory results. The quantity of copperas required is almost the same as that of alum. Okay, So this is all about your copperas. Take a screenshot if you want. Okay. Next is your use of chlorinated copperas as coagulant. The other one is only copperas and now it is a chlorinated copperas. That means addition of chlorine. Okay. From the name itself you can say that it is the addition of chlorine to your ferrous sulphate. Okay. So here you see when chlorine is added to a solution of copperas, that is ferrous sulphate. The two react chemically so to form ferric sulphate and ferric chloride. Okay, this is when you see copperas, it is added to your chlorine, then ferric sulphate is formed and ferric chloride is also formed. Okay, so this equation you need to remember. Then the resultant combination of ferric sulphate and ferric chloride is known as chlorinated copperas. So these two, okay, the addition of these two, it is known as your chlorinated copperas. Okay, so and it is a valuable coagulant for removing colors. So that means here if the water is colored and if you add copperas with chlorine, then this chlorinated copperas as a whole, it removes color in the water, color from the water. Okay, then again you see both the constituents of the chlorinated copperas along with lime are effective coagulants and their combination is often quite effective. The chemical reactions that take place are given below. So ferric sulphate and lime, they are adding lime and they are getting the flock as ferric hydroxide. Okay, ferric hydroxide there. Take a screenshot quickly. I will share it by today. Today, okay. This PDF I will share it to you. The next, again they are adding. First they have added ferric sulphate. Okay, you can see here it is ferric sulphate. Now they are adding ferric chloride to your lime. Okay, this also you need to remember. Then they are getting their ferric hydroxide flock. Okay, so two types of flocks or PPT. That means your this is known as your precipitation. Yes, precipitation or flock they are getting. Okay, so see here. The resulting ferric hydroxide forms the flock and helps in sedimentation. That means this ferric hydroxide, they will settle down and they can be removed. Okay. So ferric sulphate, it is quite effective in the pH range from 4 to 7 and above 9. Whereas ferric chloride is quite effective in the pH range of 3.5 to 6.5 and above 8.5. Okay, need to remember this. Okay, this pH. So this coagulant, okay, coagulant, that means your chlorinated copperas, it is very essential, it is very useful for waters that are having pH low pH. Okay, those are having low pH value, that is your acidic. Okay, acidic water, it is more effective, this chlorinated copperas. And number 4, let us see last one. Use of sodium aluminate. Use of sodium aluminate as a coagulant. So besides alum and iron salts, sodium aluminate formula is Na2Al2O4 is also sometimes used as a coagulant. So this chemical, when dissolved and mixed with water, reacts with the salts of calcium and magnesium, present in raw water, resulting in the formation of precipitates of calcium and magnesium aluminate. So, if you remember that the calcium, if calcium and magnesium salts are present, what do you call that hardness as? It is temporary hardness. Okay. If calcium and magnesium salts are present of carbonates and bicarbonates, then what happens? The hardness is known as your temporary hardness. We have already learned. Okay. So you see here, while this sodium aluminate it is mixed in the water and it gets dissolved. So what happens? It reacts with the salts of calcium and magnesium that is present in the raw water, and it results in the formation and the precipitation of your calcium or magnesium aluminate. Okay, you see here, this is the chemical reaction, and these are the flocks. Okay, these are the flocks that formed. Okay, so again you write from here, this coagulant is about 1.5 times costlier than alum and is therefore generally avoided for treating ordinary public supplies, but however it is very useful for treating waters which do not have the natural desired alkalinity and thus cannot be treated with pure alum. So since this alum it is costlier, okay, it is 1.5 times costlier than your alum. So obviously if it is so much costly, then it cannot be used for treating your public supplies. Okay, your ordinary public supplies you cannot use. So therefore if someone asks you what is the most common type of coagulant that is used for treating your public supplies, so you will say that that is alum. Okay, and somehow if you can visit any treatment plant, okay, then you can see, okay, they use alum. Last time or before that, the students of sixth semester, or I guess, yeah, sixth semester students, they were taken to this treatment plant that we have in Pan Bazar in Guwahati. Okay, so they have seen how a water treatment plant, the whole water treatment plant, how it works practically. Okay, so they have seen. So if you get a chance sometimes, then you can go and see. Okay, so they also use alum. Okay, so this is all about your sedimentation aided with coagulation. Okay, so four types of coagulants you have learned. Number one is your alum. Number two is your ferrous sulphate. Yes. Then your chlorinated copperas. Then number four is your sodium aluminate. Okay, four types of coagulants are used, and the most common coagulant that is used is your alum. Just remember the pH values and try to remember the chemical equations. Clear? Okay, so what's the time? 10:50. Acha. Let us quickly complete one numerical that we have. Okay, let us quickly complete small numerical. See, the question is determine the quantity of alum required in order to treat 13 million liters of water per day at a treatment plant where 12 ppm, what is ppm is also known as your milligram per liter, okay? So 12 milligram per liter of alum dose is required. Also determine the amount of carbon dioxide gas which will released per liter of water treated. Okay, I think I should end because otherwise I need to take the attendance also for 5 minutes. I need that. Okay, so this numerical we will continue in our next class. Okay, we will continue from this numerical. Just remember. Okay. Okay then. Uh, Let me take your attendance. number 1,
Yes, ma'am.
2,
Yes, ma'am.
3,
Present, ma'am.
4,
Ma'am.
5, 6, 7. 7 is present.
Present.
7, I can't hear you. Are you present? 7?
Yes, ma'am.
Okay. 8,
Present, ma'am.
9,
Present, ma'am.
10, 11,
Yes, ma'am.
12,
Present, ma'am.
13,
Yes, ma'am.
14,
Present, ma'am.
15, 16, 17, 18,
Yes, ma'am.
19,
Yes, ma'am.
20,
Present, ma'am.
21, Wapang Limba,
Yes, ma'am.
22,
Yes, ma'am.
23,
Yes, ma'am.
24,
Yes, ma'am.
25,
Present, ma'am.
26,
Present, ma'am.
28,
Yes, ma'am.
okay, 29,
Yes, ma'am.
30,
Present, ma'am.
31, 32,
Present, ma'am.
33,
Yes, ma'am.
34,
Yes, ma'am.
35, 36, 37, 38, 39, 40,
Yes, ma'am.
41,
Present, ma'am.
42, 43,
Yes, ma'am.
44,
Yes, ma'am.
45,
Present, ma'am.
46,
Yes, ma'am.
47,
Present, ma'am.
48, 49, 50. Okay, now listen to the absent ones, okay? 5, 6, 10, 15, 16, 17, 27, 31, 35, 36, 37, 38, 39, 42, 48, 49, 50. Okay, others I have given present. Okay, then see all of you in the next week.